Hello again. In this video we will continue the second part of chapter 5, DC voltage. In the previous video we finished most of the objectives which are related to voltage. We have seen that voltage is a pushing force represented by U measured in volts. We have seen that the voltmeter is able to measure the voltage. It is connected in parallel where V and COM terminals are used. The voltage could be zero if we are measuring it across a connecting wire, a closed switch, or a load in an open circuit. And it shows a specific value if we are measuring the voltage across an open switch in a circuit, across the generator, and across the terminals of a load if the circuit is closed. We still have 2 points to be discussed at the end of this video. Now it's time to talk about the intensity of electric current. As we have known before, electric current is the flow of electric charges in an ordered manner. Once we talk about the intensity of current, it's the rate at which the charges flow across a point in a circuit. Let's have a look at this figure. Here we can see the movement of electric charges. So we have current. If we ask about the flow of electric charges, they move from the negative terminal of the dry cell to the positive terminal. What if they ask about the current? It is represented by this moving red circle. It moves from the positive terminal of the dry cell to the negative one. So, if they ask us also to represent the flow of electrons on a circuit, we said that it moves from negative to positive terminals. So this is the direction of electron flow. But if they ask us to represent the conventional current, it's going to be from the positive terminal to the negative terminal. The symbol of the intensity of current is I. It is measured in ampere. And concerning the unit, just like that of voltage, it can be expressed in ampere or milliampere. So if you want to move in this direction, so we have to multiply by 1000. But if you want to convert from milliampere to ampere, it's divided by 1000. Concerning the instrument which helps to measure the intensity of current, we can use the multimeter. However, the multimeter in this case is going to be used as an ammeter. Here is the multimeter, and this is the symbol of an ammeter.
Put the electrodes inside the COM terminal and one of the current terminal. Put the selector on the current zone. Connect the ammeter in series, A to the positive terminal of the dry cell and COM to the negative terminal. Switch the connection of the ammeter. We will see that the ammeter indicates a negative reading. So, for the ammeter to give a positive reading, A must be connected to the positive terminal of the dry cell and COM to the negative terminal of the dry cell.
So if you want to summarize the way of using an ammeter, first of all, we have to use the COM and A terminals. Have a look right here. This is the COM terminal and this is the A terminal. Similarly for the other figure. Second, we have to choose the zone specific for current. Here is the zone, and pay attention for the symbol right here. It's a direct current. Similarly for the other figure. The multimeter should be connected in series, acting just like a part of a circuit along the same path. For example, this is a dry cell. Then along the same path we have the ammeter. Here we have an electric component, and back to the dry cell. Here I have to give you a note concerning ammeters. An ammeter acts just like a connecting wire it shows negligible resistance. It only allows the current to pass through it in order to measure its intensity. If COM terminal is connected to the negative terminal of the dry cell, then the reading is going to be positive. And if we switch the connection, the reading is going to be a negative reading. So if we check right here, COM is at the negative terminal of the dry cell, so we expect to read a positive reading, and in case of switching, it shows a negative reading.
In order to find the intensity of the current of this dry cell or of the main current, we have to use the ammeter that must be connected in series. I'll cut this wire and bring the ammeter. So the intensity of the current, or that of the main current that is sent from the dry cell, is 0.45 ampere. What about the intensity of the current of the first lamp and that of the second lamp? Okay, it's also 0.45 ampere for the first lamp. Also, it is 0.45 ampere. What can you conclude? The current that passes through the lamps grouped in series is the same as that of the dry cell. In order to find the voltage of these lamps and that of the dry cell, we have to use the voltmeter. So we have to connect this voltmeter in parallel across the first lamp to find the voltage. So the voltage of this lamp is 4.5 volt. For the second lamp, the voltage of the second lamp is 4.5 volt. What about the voltage of the dry cell? The voltage of the dry cell is 9 volt. Let's now replace one of these lamps by another kind of lamp. So the voltage of the first lamp is 0.82 volt. That of the second one is 8.18 volt. That of the dry cell is 9 volt. So, what can you conclude? What is the relation between the voltages of these lamps and that of the dry cell? Look at these values of voltages of the lamps and dry cell that are obtained in these two circuits, then try to find the relation between them. .5 volt plus 4.5 volt gives 9 volt, and 0.82 volt plus 8.18 volt gives 9 volt. So, the sum of the voltages of the lamps that are connected in series is equal to the voltage of the dry cell.
So, in brief, in series grouping, the first load to be taken is the load related to voltage. And as you have seen in the video, we have additive voltage in a way that the main voltage is equal to the sum of the voltages across the different components. Note that if the components are identical, for example, if we have two identical lamps, then we can divide the voltage on them equally. Have a look at these. Here we have the main voltage, the voltage of the generator, which is about 9 volts. And here we have two identical lamps, 4.5 volts and 4.5 volts. Concerning current, in a series grouping, we have the law of uniqueness of current, which means that the current is the same in all the components of the circuit. So the main one is equal to the components, the current traversing the other components. Keep in your mind that in series grouping, the components are present along the same single path. Just check the value right here and here.
This is an electric circuit where the lamps are connected in parallel. To find the intensity of the main current that's sent from the dry cell and the intensity of the current of the lamps, we should use 3 ammeters that each is connected in series with the corresponding electrical component. The intensity of the main current that's sent from the dry cell is 1.8 ampere. That of the first lamp is 0.9 ampere. The intensity of the second lamp is also 0.9 ampere. Let's now replace one of these lamps with another kind of lamps. The intensity of the main current that is sent from the dry cell is 0.91 ampere. That of the first lamp is 0.01 ampere, and that of the second lamp is 0.9 ampere. What can you conclude? What is the relation between the intensity of the current of the dry cell and that of the lamps? Look at the values of the intensity of current of the lamps and dry cell that are obtained in these two circuits, then try to find the relation between them. (0.9 ampere plus 0.9 ampere gives 1.8 ampere, and 0.01 ampere plus 0.9 ampere gives 0.91 ampere. So, the sum of the electric current of the lamps connected in parallel is equal to the main current of the dry cell. Let's take it from another point of view. If you remember, we resemble the flow of the electric current by a flowing river. Look at this picture. It is a flowing river that reaches two branches. Then the river will be divided, and if you sum up these parts, you will return to the main current. This idea is very similar to what we did in parallel circuits. The electric current reaches to two branches, then it is divided, and at the end, they are added to return to the main current. What is the relation between the voltages of lamps and that of the dry cell? To measure the voltage of these components, we have to use the voltmeter that is connected in parallel. The voltage of this lamp is 9 volt. Of that lamp is also 9 volt, and of the dry cell is 9 volt. What does this mean? This means that the voltage of the dry cell is equal to the voltages of the lamps when they are connected in parallel.
So in parallel grouping, the first law to be taken is the law of additive current, which means that the main current is equal to the sum of the currents traversing the different components. If the components are identical, then the current will be divided on them equally. For example, this is the main current, and these two lamps are identical, then check the branch currents, 1.5 and 1.5. Concerning the voltage, we have the law of uniqueness of voltage, which means that the main voltage is equal to the voltage across the terminals of the different components. So 1.5, 1.5, and 1.5. Now let's move to summarize everything related to voltage. These objectives were covered in the previous video, and today we have seen that the voltage is the same in parallel grouping while it's additive in series grouping. Concerning current, current is the flow of charges represented by letter I and measured in ampere. To measure the current, we use an ammeter which is connected in series, and the terminals to be used are the A and COM terminal. We can get zero value of current if the circuit is open and in the absence of a generator, in the absence of voltage. Current is the same in series grouping, but it is additive in parallel grouping. So this is everything about this lesson. And at the end, I have to thank you for your attention.